Hello, everyone. Let's get started. I hope you're doing great. It's been a great conference so far. Today, I'm going to talk about serverless Java with Spring Boot. Let's get started by talking about what serverless means. I have asked you through the conference app what is serverless, and I got a lot of different answers. It was quite interesting because if we think about it in our industry, we use certain specific terminology to mean a very well-specific concept so that when we talk with each other, we understand each other very clearly. Think about the software design patterns. If I say singleton, proxy, adapter, decorator, we all understand what they mean. We are all thinking about the same thing. But if I say serverless, each of us is probably thinking about something different. So I might try to define serverless, but that's pointless, it's meaningless, because then every time I talk with some new person about serverless, I have to start by defining what I mean by serverless. So instead of doing that, I'm going to talk about 5 themes, 5 topics that usually are considered when we talk about serverless. The first one is the literal meaning of serverless, which means no servers. But of course, there are servers, right? What does it mean, no servers? Also, what is a server? That's also a bit of an ambiguous word. So maybe we can say no infrastructure. That makes a bit more sense. But of course, our applications require infrastructure to run. So the idea behind this is actually that as developers, we don't care about infrastructure. We don't deal with infrastructure directly. Instead, we have a platform. We introduce the concept of a platform in order to take care of all the infrastructural concerns for us. So we want a platform that can take care of provisioning infrastructures, that can take care of managing workloads, and also a platform that can dynamically scale our application instances. So if there's more traffic coming in, I want the platform to take care of scaling instead of dealing with that myself as a developer. And if we do that, if we introduce such a platform, then as developers, we can really focus on the business logic. We can focus on implementing the business requirements, the code that implements those requirements that ultimately deliver value to our end users and our customers. That's the primary thing that I like to mention when talking about serverless architectures. Developers focus on the business requirements. And then the fact that there's no infrastructure means that there's no infrastructure for developers to manage, but there is a platform that takes care of all of that. So what does it mean for us? If we're working with Java, I can focus on building, for example, a Spring Boot application. I implement the business requirements. At some point, I package it perhaps as a jar artifact, and then I can use a platform to deliver that jar artifact and let platforms like AWS Lambda or Azure Functions or Google Cloud Functions to take care of the rest. So I just provide the jar file, and the platform takes care of everything. Or maybe I package it as a container image. That's also an option. And then I can deploy my application on a platform based on Knative on top of Kubernetes. So the idea here is we provide an artifact to the platform, and the platform takes care of everything that is necessary to run the application and keep it running, including scaling to support more users, more use cases. So if we are using AWS Lambda, for example, we can use the AWS Lambda CLI, and this is just a short version of the actual command that we would run, but the key part is we are providing a jar file. Just the jar file. Everything else is handled by the platform. If we use container images, then I can rely on Knative taking my container image and deploy it in a production environment, scaling that, allocating all the resources that I might need. Let's have a look at an example. I have already installed a platform, a minimal platform on my laptop, and I have implemented an application. I have containerized it. So now what I can do is go into my terminal, and I can use the Knative CLI, or in other AWS Lambda, you have the AWS CLI or the Azure CLI. So the CLI provided by the platform. And I can create a new service. Let's call it web function. And I only need to provide, in this case, the container image. On AWS Lambda, I would provide a jar file. In this case, I'm working with containers. So I point to my container image that I have previously built and pushed to a container registry. It's called Web Function version 1. There it is. Now the platform takes care of all that is necessary. I even get one instance of my application running, and I get a convenient URL that I can use to call my application. So now I'm going to use the HTTP CLI in order to send an HTTP request. This is the URL. The application is expecting to receive a musical instruments. So I can say name guitar, for example. And then you can notice that I even get HTTPS. But I'm running locally, so I want to ignore the verification of the certificate because it's self-signed. So I need to say verify no. And there it is. My application is working. I pass a musical instrument name, and I get back a sentence, I play the guitar. But that was one request. What happens if I send 200 requests, for example? What happens is that the application is scaled automatically by the platform. You can see we have 2 instances. We have 3 instances. Depending on the workload, the platform takes care of scaling up my application. Again, as a developer, I don't need to deal with this. It's something that the platform provides out of the box. So it's transparent to me as a developer. All right. Now, I'm not going to talk too much about platforms today. I want to focus on the developer side of things. But if you're interested about platforms, about what is a platform, how do we build one, I can recommend checking out this white paper. I was part of the working group that authored this white paper for the Cloud Native Computing Foundation, so I can recommend checking that if you're interested on the topic. Instead, moving on, I want to focus on what does it mean for a developer working with serverless application. So we said, first thing, we want a platform that takes care of all those infrastructural concerns, including dynamic scaling. But then, what happens? Like right now, there's no request coming into my platform calling my application. So perhaps it doesn't make sense to keep any instance of my application up and running. And that's the second theme I want to address today, that is scaling to zero, which is usually something that is considered when we talk about serverless. Scale to zero means that if there's no request to process, no event to handle, we can completely shut down all instances of our applications. So we have 0 instances up and running. And scaling to zero is actually quite simple. Like a more interesting topic is scaling from 0. Because if we have 0 instances of our application and suddenly a request arrives, we need 2 conditions to be true. The first one is the platform should immediately spin up a new instance of our application. And the platform takes care of that, so I don't need to be worried about that as a developer. But the second condition is that our applications need also be able to start up quickly and immediately start processing the new request. And that's quite of a challenge. Historically, Java has not been good at starting up fast. And the reason for that is that Java, when we compile a Java application, we compile it to something that is called bytecode. That bytecode is what we run on the Java virtual machine, and dynamically at runtime, that bytecode is converted to the machine code that ultimately is executed on the operating system. That's why we say that with Java, we write once and run everywhere. Because this bytecode, we can use it across different operating systems. But that has some downsides, of course, because it means that starting up, the application needs to be compiled to machine code, so it might take a few seconds to start up. And that's really not good for serverless. So one solution to that problem is provided by GraalVM. GraalVM is a project from Oracle. It's an OpenJDK distribution, so you can use it to run your standard Java application. But GraalVM has also an interesting alternative method to compile applications, which is called native image. So instead of using this bytecode and compile to machine code the application at runtime, we want to move all that heavy computation at build time. And if we do that, then the startup time will be fast because we're moving all the computation at build time. Of course, that means that the build phase will be slower. So it's kind of a trade-off. I'm working with Spring Boot, and in particular from Spring Boot 3.0 that was released last year. We have out-of-the-box support for GraalVM native executables. So we can, almost out of the box, get a lot of benefits from it. We can get instant startup time. Usually it's below 100 milliseconds. We can get instant peak performance, which means when we scale from 0, the application can immediately perform very well and start processing new requests. We don't have the warm-up phase anymore. We also get a low resource usage, which is actually quite great because serverless is associated to pay-per-usage. So if we have applications that consume less memory, it means that we're paying less. This is good both for cost optimization, but also to be greener, to think about the environment and consume less if it's really not necessary. We also have a reduced surface attack, and this is sometimes overlooked. Because the way that GraalVM works is that it starts from your main method and starts compiling everything that is reachable from the main method. Everything else is discarded. So if you are using a third-party dependency, and that dependency, for example, has a feature that is affected by vulnerability, but you're not using that feature, you're not using that code, in a standard Java application, you are still vulnerable because that code is part of your jar file, so it can be used for doing some remote code execution, for example. Exploit it and attack your application. But with GraalVM, if we are not using certain parts of the code, that code doesn't end up in the final artifact. So even if you're using a third-party dependency that is vulnerable, because you're not using that part of the code, that feature, you are not affected by that vulnerability, simply because the code is not compiled in the final artifact. And finally, we get a more compact packaging, especially if you're working with container images, because we don't need the Java virtual machine anymore. We are building native executable that run directly on the operating system. Of course, there's no silver bullet. So there are some downsides, and I mentioned one, which is the build time is a bit longer. Now, each version of GraalVM improves this part. I tried the last version of GraalVM released 2 weeks ago, and I usually manage to compile my application with GraalVM within 50 seconds, which is great. Like 2 years ago, you would have to wait even some minutes. So now it's below 1 minute, typically. The other one is that you might need some additional configuration. Because all the computation happens at build time, the compiler might need some extra information, especially if you're talking about reflection or dynamic proxies. So I want to show you an example. I'm going to build a new Spring Boot application. I'm going to start.spring.io. I build a new application with Java, Gradle, and Spring Boot 3.1. And I want to add 2 dependencies. The first one is the GraalVM native support, because I want to compile my application as a native executable. And then I'm adding Spring Reactive Web. I want to build a simple web application to showcase what GraalVM can do. This is my application. Now, I want to expose an HTTP API. I'll define a record of type artist, like that. And now I can go ahead and create perhaps a REST controller. I could do this. I'm not going to do this because REST controllers work out of the box. I want to show you a case where we need additional configuration. So if you're using REST controllers, everything will just work because Spring provides all the necessary configuration to the GraalVM compiler. So instead of using a REST controller, I'm going to expose the API in a different way so that we can see what happens if, for example, we run into reflection issues. So I'm going to create a bin of type router function. This is an alternative way to create a REST API. Then I can say router functions. I want to build a new route. And I want to expose 2 endpoints. One is the root endpoint for GET request. And for that, I want to build a response, 200 OK. And in the body, I want to add GraalVM rocks. All right. And then second endpoint, still a GET request. I want to return a list of artists. So given a request to that endpoint, once again, 200 OK. So you can see this is a bit lower level compared to the REST controller. And in here, I can add a list. And I'll hard-code it for the demo. So let's see, new artist, Deep Purple. Led Zeppelin, and Blackberry Smoke. All right. Now, from Gradle or Maven, I can run the specific command to compile it as a native executable. In Gradle, there would be native compile. Now, it takes a minute, so I have already done that. So cheating a bit here. So I'll run the native executable. And you can see it started below 100 milliseconds. Now I can verify that the API is working correctly. So root endpoint, perfect, is working. Let's see the artist endpoint. And I get an internal server error. Now what happened here is that Jackson, the library used to serialize my artist record into JSON, is using reflection. And GraalVM needs to be instructed to enable reflection on the artist object. If I use REST controllers, Spring provides that configuration for me out of the box. But because I'm doing it in this different way, I have to explicitly tell GraalVM to support that feature. And Spring provides some annotations to do that. So I can say register reflection for binding as an annotation and point to my artist class. And that's it. Then Spring automatically converts that annotation into the specific JSON configuration required by the GraalVM compiler. So if I compile my application again, we can verify if it's working. Root endpoint, still working. Artist endpoint now is working as well. So GraalVM is really great for the serverless use case. Spring Boot, starting from version 3.0, provides a lot of configuration out of the box. You might run into situations where you need to provide this additional configuration. And typically, you can get away with it by adding some annotations or some specific beans in order to enable reflection or dynamic proxies, for example, on some of your classes, in those situations where Spring cannot infer that for you. All right. So if we go back to the previous application, we can see that because there were no requests, there's no application instances running. So what happens if I send a request now? Now I get an instance. It's very fast. I get the response. And the platform took care of scaling from 0. But I had to compile my application as a native executable in order to get that instant startup time and instant peak performance. So Java can be serverless, but we need to do it in the right way in order to enable that use case. Now, GraalVM is one option and is very nice not only for the serverless use case, but also for other benefits. I mentioned security and reduced memory consumption, but there's also other options to do that. For example, Crack is an interesting technology that can be used to achieve that instant startup time and instant peak performance. And the way that it works is you still have your standard Java application, you run on the Java virtual machine, but the artifact that we deploy in production is not directly run from my application artifact, because the first time I run it, I let the application run and initialize, I take a snapshot, and then the next time I'll start the application from this snapshot. This technology will be supported natively in Spring Boot from version 3.2 later this year. It's also used by AWS Lambda. So if you're working with Java applications for serverless on AWS Lambda can use Crack for you in order to generate this snapshot so that you can get almost for free this instant startup time and instant peak performance. Great. We talked about the importance of a platform, how to scale to 0, and most importantly, how to scale from 0. And for Java, we need to take care, for example, using GraalVM or Crack, to achieve that instant startup time and instant peak performance. But now let's talk more about how to work with our business logic. Because I said at the beginning, as developers, we are empowered now to focus more on the business logic. And if we put aside for a second all those infrastructural concerns, if we really want to focus just on the business logic, Then we can start thinking about what are the inputs and what are the outputs of our business logic, without considering how that input is coming into my application and what happens with the output. And with that mindset, working with a functional programming paradigm can really help. That's why functions are usually mentioned when talking about serverless. They're not required. It's just at an abstract level a way to think more about inputs and outputs for our business logic. So serverless doesn't mean break down all your application logic into functions. But it's a paradigm, it's a programming paradigm that we can use if it makes sense. And in particular, when working with Java, since Java 8, we have a series of functional interfaces we can use to implement our business logic as functions. We have the supplier, the function, and the consumer interfaces. So the supplier produces some output, the functions take some inputs, does some processing, and then output, and consumer just consumes some input. Let's have a look at the previous example. Actually, let me show you this first. So this is the business logic for today. I want to provide the instrument name, and we saw that in action already. And I want to use two functions composed together to fulfill the business logic. The first function will convert the musical instrument into uppercase. The second function will build a sentence. I play the piano. Let's do that. All right. So now I'm working with standard Java. There's no framework involved here. So I can create a first function. I'll need two records. One is called instrument. And the other one is called skill. Like that. So I can create an init function that takes an instrument as input and a string as output. Let's call it uppercase. And then another function that takes a string as input and skill as output. And we'll call it sentence. Now, to follow what's going on, I'll also add a logger. So logger from SLF4J, like that. Logger, factory, and get me a logger. All right. So the first function takes an instrument. So I can say instrument as input, and then I'll do two things. First one, I'm going to log that I'm converting to uppercase the instrument. Instrument.name. And then I'll actually do that. So I can say instrument.name.toUppercase. Let's import the function. So that's the first one, standard Java. Second one, same thing. Takes the instrument name as input. We log a message, building sentence with the musical instrument provided as input. And then I can return a new object of type skill with the phrase I play and the musical instrument name. All right. Now I'm using functions, but I can use also suppliers and consumers. For example, I can create a consumer here that takes a skill and print it. So I can say skill and then log.info skill.content. Perfect. Now Java provides some functionality in order to compose functions together. So for example, I can create a test method in here. I can take the first function, uppercase, and then I can use this and then method that is provided together with the function interface. So I can say uppercase and then execute sentence, and I want to apply this function composition on a specific musical instrument, guitar. Now, this is great, but there are a few problems. First problem, the output of the first function needs to be exactly the same type as the input of the second function. So if in the second function I want to have an instrument object, that will not work. Second problem is I want to declare this composition not in a programmatic way. I want to externalize this configuration somehow. And finally, I have an issue because I can only combine together functions with other functions, consumers with other consumers. So I cannot say uppercase and then sentence and then print. They will break. So what do? We want to keep the logic like this, standard Java. We don't want to touch it. But on top of this, we want to enhance these functions, as I said, to provide enhanced capabilities to compose them together and to declaratively configure them. And that's where Spring Cloud Function comes really handy. So we start from our business logic implemented as Java functions, or consumers or suppliers. And then, without changing anything in our code, we can introduce Spring Cloud Function, which is a thin layer wrapping our functions and enhancing those functions with additional capabilities. And we get quite a few capabilities. For example, we get transparent type conversion. So I don't have the problem of output of the first function that needs to match the input of the second function, because the framework can do that for me. I can compose together and mix and match functions, suppliers, and consumers, and I can do it declaratively, so I externalize that configuration. I can also work with multiple inputs and multiple outputs. That's called functionality. And I can even start collecting my own personal catalog of Java functions, each function packaged as a jar file, and then I can combine them together into an application using Spring Cloud Function in order to enhance them all. And finally, I can combine together imperative and reactive functions. So far, it's all good. However, just implementing the business logic doesn't really help us. Somehow, we need to call that business logic. So after talking about the importance of platform, scaling to and from zero, and functions as a way to implement our business logic, it's time to look at how we consume that functionality. And in particular, we need to talk about triggers. Triggers are really important when we talk about serverless, because that's how the platform then can manage the dynamic scaling, for example. Because the only way that the platform knows when it's necessary to maybe spin up more instances or scale to zero is if we define a clear trigger for that function. So what can we do? We have our Java functions. We have Spring Cloud Function. What we can do is actually using Spring Cloud Function as a way to protect our business logic from all these external integrations, because we can integrate functions with different platforms, with different technologies, but we don't really want to change the business logic, because a concern when we talk about serverless is vendor lock-in. So if I start deploying my functions on AWS Lambda and tomorrow I want to do it on Azure Functions, I would like to have to do as few changes as possible. And with Spring Cloud Function, we protect our business logic from any change, because the integration layer now is outside Spring Cloud Function. So for example, I can add a specific adapter for AWS Lambda that works with Spring Cloud Function and provides a way to configure the trigger specifically for AWS Lambda. But our Java function is still the same. No code changes there. And that works the same for other platforms. So for Azure Functions, I simply replace the AWS Lambda with the Azure Function dependency. Of course, I need to change the configuration, which is specific to Azure Function, but my business logic remains the same. No changes there. Google Cloud Function, same thing. I swap a dependency, I provide the specific configuration for that platform, and I still protect my function. But that doesn't have to be necessarily on one of these cloud platforms, because serverless can also mean working with containers and working on Kubernetes. So we can use Spring Web. Spring Web is an integration layer to make able the functions to be consumed via HTTP endpoints. So if I use Spring Cloud Function together with Spring Web, I can build applications that run as any other Java application or GraalVM native executable, or I can containerize them and run on Knative on top of Kubernetes, which is exactly what I did at the beginning. The demo I showed was with this specific configuration. So let's have a look at how it works. If I go back here, I want to create a new project. I'm going to add 3 dependencies. The first one is Spring Cloud Function. I want to add support for GraalVM, because I want to enable the scale from zero use case. And then I'm going to add Spring Web. So if we go back to the application now, you can see that in Java, I have the same exact logic as earlier. I have two functions and the consumer. The only difference is that they are annotated as beans. That's how we tell Spring Cloud Function to enhance those functions for us. That's the only change. I annotate them as bean. And then if I go to the application property file, I can specify my function composition, the overall composition enabling that business logic. So Spring Cloud Function definition. And here I can pipe together all the functions or consumers or suppliers that I want. So I can say uppercase, pipe, sentence. In order to achieve that uppercase and then sentence, I can even pipe the print. But I'm going to do with just uppercase and sentence here. Now I'll start the application. All right. Now I'm going to send an HTTP request to port 8080. And Spring Cloud Function exposes automatically my function composition through the root endpoint. So if I send the musical instrument in here, then I get back the message. But it does even more than that, because that's the combination that I specify via the configuration property. But I also have access to all the functions. For example, I can call uppercase directly with /uppercase, and that's out of the box. I'm not configuring that. Like that. And I even can compose on the fly these functions if I need to. So I can say uppercase, sentence, print. In this case, I'm using the comma. And now I get back nothing, because my function definition ends on a consumer, which has no output. But that consumer is printing things out on the logs. So if we check the logs, we can see that the final sentence is printed out. All right. This is the out-of-the-box behavior, but of course you can configure it. So if you only want to have the overall cloud function available, then you can disable the automatic generation of those endpoints for all the other functions. So once again, our Java function, we don't change anything in there. We wrap it with Spring Cloud Function that provides in a transparent way all this extra functionality. And on top of that, we can integrate our functions, our application, with different platforms and different logic. So I mentioned serverless platforms like AWS Lambda or Azure Functions. I talked about Spring Web. But if we consider the way that we're working with functions and this idea of triggers, we might start thinking also about event-driven applications. And that's the fifth and final theme I want to talk about today. If we implement our business logic as functions, then it becomes natural to think that the input might come from a message queue. It doesn't have to be HTTP. And that's true both if we are using a public cloud platform or if we are using a platform based on Kubernetes. But it's even true if you're not working with serverless at all. But using the power of Spring Cloud Function, what we can do is, again, same Java function, layer with Spring Cloud Function, and this time I can integrate my functions with message queues using Spring Cloud Stream. Spring Cloud Stream enables the binding between our functions and external message queues, for example, RabbitMQ or Kafka, or both of them at the same time. So one function binding to RabbitMQ, the other function binding to Kafka, which is quite convenient because then we can once again protect our business logic from those infrastructural concerns. That's overall the main theme, the main idea of serverless, the developer experience part. I want to focus on the business logic. I shouldn't be needed to change my logic if I want to consume my function through HTTP, through AWS Lambda, or through RabbitMQ. And that's what Spring Cloud Function enables in the Spring ecosystem. So let's have a look at an example. Now, if I keep the same project as before, I can add on top of that the Spring Cloud Stream dependency. And then I have to specify what kind of messaging layer I want to enable. And I'm going to choose RabbitMQ. So going back, I have my new application, but the logic is still the same. Uppercase function, sentence function, and print consumer. And I have my cloud function definition that pipes together uppercase and sentence. So the only change compared to the previous project is that I added the Spring Cloud Stream dependency and the RabbitMQ adapter. So what happens if I start the application now? Let's find out. I'm going to run it with boot run. Like that, yes. So now the first thing that happens, and is really not related to serverless, is that Spring Boot is spinning up a RabbitMQ container for me. And I didn't have to start it up manually. So we can see that there is a RabbitMQ container running. It wasn't running before. And the way that it's working is because I'm using Spring Boot 3.1. From Spring Boot 3.1, if I add a compose support dependency, Spring Boot will generate a Docker Compose configuration to spin up all the external dependencies that I mentioned in my initialization. And because I mentioned that I want to use RabbitMQ, Spring Boot generated a Docker Compose file with RabbitMQ. We can see if we explore the project that is initialized, I get a compose YAML file. So Spring Boot will run this Docker Compose file during the startup phase. It will configure the application using those credentials as well, and the URL pointing to this container. And that's out of the box. So if I generate this project, I run it normally with Maven or Gradle, and I get RabbitMQ running. But that's only one option, because another option is using test containers. And that's my favorite way of working, because test containers, I can use it both at development time and when writing integration test. So if I add the test containers dependency, my application will contain an extra configuration where a RabbitMQ container is configured. It will be started up both when I run integration test, but also when I run my application from this configuration file. And this is even better than Docker Compose, because now I have one single configuration for RabbitMQ, which is shared between development and testing. Because usually, when working with test containers, is that you use it only for integration testing, and then you have a Docker Compose file for development. And let's say you update the version of RabbitMQ, you have to change it in two places. But now we can share the same configuration, which is created when bootstrapping a new project from start.spring.io, and Spring Boot will manage the lifecycle for us. And then we can see that I get the management console for RabbitMQ. All right, yes. And if we check the exchanges section, we can see two exchanges that have been created automatically, starting from my Spring Cloud function definition. So we have an uppercase sentence input and an uppercase sentence output. This is the default naming. Of course, we can configure it and customize it. But now, if I send a message to the uppercase sentence input exchange, let's do that. Let's go with drums this time. I publish the message published. If we check the logs for the application, we can see two log messages. The first saying converting drums to uppercase, and the second one saying building skill with drums. So my function has been triggered by RabbitMQ. And in the same way, I can listen to queues. I'm not listening right now on any queue, so it's not part of this application. But then once again, it's very transparent. I keep my business logic intact, and then with Spring Cloud Stream, then I can configure the integration layer. And now I'm using RabbitMQ. If tomorrow I want to use Kafka, I can change the dependency. So Spring Cloud Stream works on top of Spring Cloud Function and allows to integrate our functions with different message queues, not only like RabbitMQ or Kafka, but also message queues provided by cloud providers, like on AWS, on Azure. There are different adapters in the community. And what we get is integration with event brokers. This is, in general, for event-driven applications, so it doesn't have to be a serverless use case. We can use it for standard event-driven applications. We get binding with functions in a very transparent way. The model that is used is publish, subscribe. And we get advanced features like consumer groups and partitions as well. So of course, if you're using Kafka, for example, we also can configure the specific Kafka features that are provided. Like Spring Cloud Stream is an abstraction, but we can always rely on the specific features of the specific broker that we are using. So that was the 5 main themes that I wanted to talk about with serverless. Platform, we need a platform that takes care of all the infrastructural concerns. Scale to zero and scale from zero. Our applications need to start up quickly and also be performant enough to start processing our request right away. We talked about functions as a way to basically implement our business logic. It's a programming paradigm. We don't need necessarily functions for serverless. The first example I showed with GraalVM, that's also serverless application in my book, and I wasn't using functions. Then we talked about triggers, and triggers are how we configure the integration with a specific platform. And the trigger is what tells the platform how to do the dynamic scaling. And then we also talked about event-driven applications in general, built on top of all these different aspects. Now, I want to talk about a bonus theme, a bonus topic, because as I said, developer experience is quite important with serverless. We want to free developers from thinking too much about the infrastructural concerns, because there's a platform taking care of that, and there's a platform team with all the expertise and skills to keep the application up and running and develop new features so that developers can focus on code. And there are a couple of things that I've been doing during the presentation I want to expand further on. The first one is how I build container images. Because I showed an example with container images, and if you check my project, I have no Docker file. What I did was running a task from Gradle called boot build image, and automatically I obtained a container image. So what's going on there is that, to quote Josh Long, friends don't let friends write Docker files. I haven't used any Docker files because writing Docker files is easy, but writing Docker files for production is really not. There are so many concerns about security and performance, and furthermore, if you put a Docker file in your application project, then it's over. Like, you as a developer are responsible for it. You are responsible for maintaining it up to date, to maintain it secure, and apply patches. But if I'm adding all this extra complexity, because it's extra complexity working with serverless, in order to be able to focus more on business logic, then it doesn't make that much sense to have Docker files. Because on the one hand, we are improving our experience. On the other, we are adding extra responsibilities on the developer desk. And I want to remove that. That's why I use cloud-native Buildbacks. And this is supported out of the box in Spring Boot. It works with any kind of languages. So if you work with whatever framework or language, then you can use Buildbacks in order to convert your application source code into a container image directly. And that container image will be production ready, will be secure, will be performant. And the good thing is that you don't even need to install additional tools, because in Spring Boot, you can do it directly from Maven or Gradle. For example, from Gradle, I run the boot build image task. Now, the final thing is, when working with containers and with Knative, we can improve things further, even more. Because what if we skip entirely having to go through this step of containerizing our application? That's what the Knative Functions project allows us to do. With Knative Functions, what we do is we use the Func CLI. We say func create and create the project directly. It could be a Spring Boot project, a Golang project. And then I can simply say func deploy. And then the CLI will take care of using Buildbacks under the hood to containerize my application and to deploy my application on top of Knative. And then I get back a URL. And this is great because as a developer, I only need to care about 2 things. The first one is the application code. The second one is I get the URL back so I can call my application and test it. So I want to quickly show how that works because it's a quite convenient flow. Yes. So I'm going to run this func create command. So I can say func create, and then I specify the specific language or framework. I'm saying I want to work with Spring Boot. I specify the trigger, and we talked about trigger. In this case, I want the trigger to be HTTP. It could be based on events. I want HTTP. And then I'm pointing to a repository of templates. Now, Knative comes with its own repository. In this case, I'm using one of my own. And that's it. I get the project. Now, if we look at the project, we can see that it's exactly the same as the other projects I've been working on so far. There's even a sample function. So at this point, I can say func deploy, and my application is containerized and is deployed to the platform all automatically under the hood. So I can improve my developer experience even more. Great. Now, all this source code is on GitHub, so I'll share afterwards both the slides, and you can check my GitHub repository for that. I'm Thomas Vitale. I work as systematic as a software architect and engineer. I work with cloud-native technologies and with Java. I'm really passionate about those. I combine these passions of mine to write a book. It's called Cloud-Native Spring in Action. And I'm really passionate about open-source technologies. I try to contribute as much as I can, both in the Java space and in the cloud-native ecosystem. That was it for today. Thank you very much for joining. I hope you're going to have a great rest of the conference, and see you next time. So if there's any question, I think we have a few minutes for that. Do we have a microphone?
Hi, thank you. I have a question about the granularity of packaging. Imagine you have several functions about the same domain. You mainly want them in the same repository because they're about the same entities and same business logic. But then you might not want to deploy all of them in the same application. You want maybe to split in between applications, not maybe one application by function, but something in between, depending on scaling and everything, or the trigger maybe, or stuff like that. What's your experience on this?
So I think it's important to be really careful about that, because just like with microservices, it's important not to start breaking down our application too much. Because a common mistake is now everything is a function. So now we go from maybe having 10 services to 100 functions, and that's simply unmanageable. So I don't have a general rule for that. I would probably point to the same reasonings that I would use when working with microservices, like if it makes sense to have it as a standalone, if it makes sense to scale it independently or deploy it independently or develop it independently, then it might be on its own. But I would be very careful to have any function being independent from each other. Actually, in the latest Spring Cloud Function project, there's a new functionality where you can take your standard web application using REST controller, for example, and then using the AWS Lambda adapter, that's converted automatically in a series of functions. So from the AWS Lambda perspective, you have at the same time a lot of different functions together, but the deployment unit is the same one. Because if it made sense to have it as the same one as a standard application, then it might make sense to have the same one on AWS Lambda. So that's an option that I would consider rather than starting breaking everything down into independent functions. Yeah. Any more questions? Yes?
Hi. So basically, two questions.
Yes.
The first one is, some months ago, we had a meetup about native, and we asked at which point we convert our code to native in our life cycle. And the answer was, well, just before going to production. And to me, that sounded very, very bad, because in the end, you will go to production with an artifact that you did not test. And the second question is, what happens to garbage collection?
Sorry, can you repeat the second question?
What happens to garbage collection?
Okay.
With native?
Yes, so about the first question, that's really interesting. So one of the downsides of GraalVM is that it's a bit slower. at compiling. So during the development workflow, locally I wouldn't use directly the native image, not yet at least. But as soon as possible, I think it's important to compile it to native. So maybe when I push my changes, then I like the pipeline to immediately not only compile it, but also run the test on the native executable. And I can do it from Gradle and Maven directly using the native test, for example, task. So I would definitely not wait until production. I would do it as soon as possible. And if there's time, maybe at the end of the day, even compile it on the laptop. It takes 50 seconds, so it's annoying if I do it continuously during the day, but maybe before pushing my changes at the end of the day, I might just run it and verify that everything is working correctly, so to get even earlier feedback. And about the second question, garbage collection still works. Like the latest version of GraalVM released 2 weeks ago introduced support for G1, which is one of the most used garbage collection in Java. So I think it used to be a concern, but from the latest version of GraalVM, not anymore at least. Yeah. Any more questions? Or maybe we don't have time, but I'll be around, so just come and talk to me if you want to. Have a great day.